today we're going to learn about quantum numbers. But before we begin, let's start with the basics of chemistry, which is atoms. Now, as we all know, an atom contains of a nucleus and an energy level, which can also be called shells. We can see in this picture that the nucleus is the solid pink and the shells are pink strings. As we zoom into this atom, we can see that inside the nucleus there is a proton and a neutron, and the electrons are sitting on the shell. Now, in a common atom, the first shell will contain maximum of 2 electrons, and the rest will contain a maximum of 8. But here is a table showing the maximum amount of electrons in each shell. Now, the atom of an element will have specific properties. Some you can change, some you cannot. If we change the electron number, it will affect the charge and cause the element to become an ion. If we change the number of neutrons, it will affect the mass number and change the atomic weight. However, if we change the proton, it's impossible. If it has a different proton, it must be a different element. Now, we move on to electronic configuration. First, we must write down a list in which we should follow to order an electronic configuration. The list template is easy enough to remember, but we must follow it diagonally as shown by the lines. The letters after the number is an orbital. Now, each orbital can hold a specific amount of electron, which is stated in the picture. So let's take an example. Bromine, whose electron number is 35. We should count diagonally until all the maximum number of electrons is added up together so that it will equal to 55. As we can see, the last quantum number is 5p5 and not 5p6. This is because an orbital can hold less than its maximum number of electrons, but not more. Let's go deeper on our numbers. Now, the first digit is a number, which is the energy level, also known as the amount of shells. Now, this can be referred to as the horizontal order of the periodic table, which is also called the period. The next digit is the ladder, which is the orbitals. They represent sections of the periodic table. The last one, which is the little number in the top, is called a lode. It represents the valencies, also known as a group number, and it is the vertical order of the periodic table. Each orbital has a specific shape, and specific amount of that orbital will occur at specific main energy level, which is stated on the table. As to not be confused, let's pretend that all orbitals are squares. We need to know how many orbitals represented by each letter. So S has 1, and P has 3, and D has 5, and F has 7. As to not forget, each orbital can hold up to 2 electrons. So to find maximum number of electrons, we can just multiply the number of boxes by 2. Don't forget that each of these boxes has numbers. The middle box is always 0, and to the right is positive, and to the left is negative. If you only have one box, so the number is just a 0. The periodic table is divided into sections of orbitals. We can see where each of the orbital sections is in this image. Let's take the example, 2p6. Now we know that 2 means the second row, and p means the p section, and 6 means the sixth column of the p section, which is over here, the shaded box. Let's go deeper into quantum numbers. So there is N, L, ML, and MS. N is the main energy level, which is the first number. L is the sub-level, which is also known as the orbital. There is a special way to list down orbitals. The SPPF is converted into numbers. S is 0, P is 1, D is 2, and F is 3. ML is the last entered electron. Now this is where the boxes come in. We will list down the number of the box where the last electron is located in. MS is the direction of the arrow. Now there's only 2 answers to this. If the direction of the arrow is up, it's positive half, and if it's pointing downward, then it is negative half. Now if you're confused, we're going to do an example together. Let's take 2d6. Now list down the quantum numbers. Before we begin filling it up, we must first make the boxes and fill it up. We know that D occurs 5 times is level 3 and up. So we must make 5 boxes. Then fill in all the electrons as arrows facing up first. Then fill in the rest facing downwards. Don't forget to put in the charge. The middle one is 0, to the left is negative, and to the right is positive. M is 2 because it is the main energy level and is clearly written in the quantum numbers. Now we should remember that orbitals are switched onto numbers. So D equals to 2, and so the L is 2. We can also see that the last electron that entered the box is negative 2, and so ML is negative 2. Remember that there are 2 types of arrow. This one ended facing downwards, so it is negative half. That's it, guys. I hope you learned useful things from this video.